Okay, so I'm just going to explain some of the stuff that I wanted to see in your work and some of the stuff I didn't want to see in your work. So, substitution, the way I taught it was that you must always change your letters for open brackets. You would then go and find out what the value of x was. So x from here was 7, and you put 7 in there. Y was 3, so that's why 3's gone on there. Remember, the definition I taught you was touching. So touching, like the 5 is touching the brackets, the 7 means timesing. So that means 5 times 7, hence 35. And this means 4 times 3, 12. And then actually working out 35 take away 12, which was 23. Now, when you're doing your work, we should only ever see one equal sign per line. I don't want to see equals going over numerous lines. It's bad mathematical practice. Technically, mathematically, it's wrong. So what we do is we have the answer coming down the page like this. Lovely. So you can see here a page of absolutely brilliant work. But what I'm not looking to see, I don't want to see this. This was some of the work I saw. I think this might have even been the same book. For substitution, I can't be accepting this. This isn't good enough, sorry. I've got to see your methods. So I wanted to see here 4 brackets plus 2. And I believe the answer was A was equal to 4. So 4 would have gone in there. That would have been 16 plus 2, which is 18. That's what that should have looked like. Okay? And again, some more work. I can't be accepting this, sorry. This isn't good enough. I'm not accepting things like this. This happened in a cover lesson. This wasn't the way I taught you. You should be replicating the work that I do with you when there's someone else teaching the class. Okay? And then what else did I have in here? I had some more good work here. I really like this. I'll tell you what I really liked here was the checklist. When I marked some books, there were some of you that did not have this checklist in there. It should have been in there. So you need to pause the video and get a copy of that checklist now. Also, some more fantastic work. I mean, look at this. This is what the same work, these questions here, was this task here and here done by 2 other people. That's not what it should have looked like. This is what it should have looked like. A little bit of feedback here as well. Here we go. What went well? Maths is correct. You can see here, this is what I was talking about before. Look, equals, equals. 2 equals on one line doesn't work. I need to see the layout going, as I said here, as I showed on the board. Brackets must be used. Answer on the next line. And I've shown a better way here. That's what this should have looked like. What I want you to do now is think about why this answer was wrong. I'm going to give you one word by here to help you. And I want you to pause the video and try and work out if you can work out what was wrong with this question. Okay then, so first things first, this line was correct. This line was also correct. This would have been worth a method mark, so this person would have already picked up 1 mark. But here is the mistake. BidMass tells me I've got indices and multiplying to do there. I've got to do the indices first. So I need to be doing 3 squared before I do 2 times 3. They've done 2 times 3 is 6 and then squared it. Okay? So it needs to be 3 squared first. So what this person should have written was 30 take away 2 brackets 9. 30 take away 18. And then the answer would have been 12. Okay, what I'd like you to do now is pause the video and attempt these 2 questions here. That is what your first answer should have looked like. And if you pause the video again, we can have a look to see what the second one should have looked like. And that's what the second one should have looked like. The way I did that was 55 take away 55 would have been 0. And I knew from 55 to 63, I counted. I said, well, 56, 57, 58, blah, blah, blah. All the way up to 63 was 8. So it told me it should be minus 8. Okay, the next thing I was going to look at, some equation stuff here. First of all, again, some people missing the checklist. If that's you and I've identified it's you, get it written down now. Pause the video. You need to have a copy of this in your book. This is an excellent solution. However, they've got a little bit confused as to what was going on here. Entirely natural because of negative numbers. Now, so far, this was only worth 1 mark out of 3. It could have been worth, by doing this step here, it could have then been worth 2 out of 3. So even if you're not sure what minus 6 divided by 2 is, you still write it because you'll get a mark. From there, you need to half minus 6. Half of minus 6 is minus 3, and that would have been worth 3 out of 3. This would have then been worth 1 mark as well. Okay? Now, I want you to have a go at this one here because, in fact, actually, I'll show you how to do this one, and then I'll get you to try one after. But I felt this was quite a tricky one, so I'm just going to double check we can do it. So 10x plus 5 equals 8x minus 1. So the first thing we should do, arrow down and put an equals, and we get rid of the smallest x. So we're going to get rid of 8x by taking away 8x off each side. That leaves you with 2x plus 5 equals minus 1. I'm then going to put another arrow down at an equals, and I'm going to get rid of anything that's not physically attached to the x, and that is the plus 5, so I'm going to take away 5. And that's where this person has gone wrong from here. The first line is actually correct, and the first line is actually worth a method mark, okay? But here's where the next mark comes in. We then get 2x on this side, and then minus 1 minus 5 is the minus 6, okay? So it's the same one as the one that we just looked at over there, okay? I just wanted to show you how you get the steps. And then we get that divide by 2 to each side, and we get the answer x equals minus 3, okay? Can you, not put a line through your work like I just did then, but can you pause the video and have a go at doing this one, please? Okay, the solution is as shown. I decided to make this one particularly hard just to show you that sometimes you don't get a number that the 5 goes into. If that's the case, you just leave it as a fraction, okay? But the marks came in 1 for doing that, method for getting rid of the smallest x, method for adding on 13 to both sides, and method for dividing by 5, and then an answer mark for getting this answer here, but it had to be 36 over 5. As long as you can see a minus 7x, that's the mark. As long as you can see a plus 13, that's the mark. And as long as you can see a divide 5, that's your mark. But it must be done to both sides like so. Okay, the next thing I'm going to do now, final bit, I think. Oh, Pythagoras and graphs. This one here, I took a photo just before I started giving the answer. I told the person who wrote this is the sort of answer I'd accept at A-level, not at GCSE. Now that sounds weird, doesn't it? Because A-level is obviously harder than GCSE. It's advanced level, whereas GCSE is what everyone has to do. However, this is not acceptable at GCSE. They need to see that you can go through the process, okay? So that's what I said to this person by here. Now, this is what I should have seen. Something like this. I should have seen the formula being written down here. I should have then seen substituted incorrectly. This line here, you could skip straight to 100, but it's a good idea to show me where 100 came from. Square root both sides. Answer is h equals 10 centimetres. This one here, done really well. This time you're given the hypotenuse, so you do the hypotenuse squared, take away the other one squared to get 49 squared. Square root both sides, 7 centimetres is equal to a. Can you have a go at doing that now using this as an excellent solution? Your teacher will pause the video now, or you will pause the video. Okay, and this is what your work should have looked like. That would be what I expect to see you be writing. Okay? Right, final bit from me. I saw a graph, and I just, instead of trying to explain what was going on, I said, see the video here, okay? So I'm going to explain how you actually draw axes, because this isn't anywhere near good enough, and you need to know how to do it. It's got the fundamental idea, but it's been done incorrectly. So I've got myself some square paper here. I'm going to try and attempt to draw a straight line. But I'm going to do that with the video on paused, okay? Okay, there we go. So I've got my axes, and they must go over a line there and there. I mean, this has been done fine on that bit here, but this is where you need to go next. I would always go across in 1 square units in your book. Now, when I'm talking about that, I'm going to zoom right in here. It's got to be on the line there is 1. On the line there is 2. On the line there is 3. On the line there is 4 and 5 and 6 and so on. It's got to be on the line. It cannot be hovering there and there. And if I go back to the example I've got here, look, that's what they're doing. Also notice this. We've got a really small gap here, massive gap here, even bigger gap here. These numbers have got to have the same size gap every single time. This isn't good enough. What I could have done if I wanted to, is I could, and I'll do this on the y-axis, because I've gone across on this graph here, as 1 square is 1, I have to go across this way as 1 square is 1. I cannot change that scale now. It's got to be what we call consistent throughout. But I can change that on the y-axis. I'm going to go up, every 2 is worth 1 on the y-axis, but that means I have to count 1, 2, count that 1. So 1, 2, and then 3 like that. You can do that if you want, but in my experience, it's much easier to use in the squares in your books to use 1 number for every 1 square. But as I said, it must be on the line, not hovering in the box, on that line. So this line is what 1 is. If you put 1 here, it could be anywhere amongst this box. It's got to be on the line. Okay?